today I actually just turned 40 and I've decided to just start making more videos and doing things that I've really wanted to do for a long time, but I've just never really put all of my energy into it. So I'm excited. My name's Andrew and I'm an exploration geologist. I've spent a good part of my career looking at old maps, old documents, old well logs, sometimes rocks, and just trying to understand the historical significance of those and how it might relate to our energy future. I'd also like to introduce my canine field assistants. This is Reese and Oreo. Several years ago, I was digging through some old USGS files, Atomic Energy Commission files, and I came upon something really weird. It wasn't your usual suspects of gold or silver or copper, but it came from a specific period in history where the world as we know it almost ceased to exist.
There was a turtle by the name of Bert, and Bert the turtle was very alert. When danger threatened him, he never got hurt. He knew just what to do. He'd duck and cover, duck and cover. He did what we all must learn.
Welcome to Project 390. We're going to dig into a series of reports about strategic reserves that faded into obscurity decades ago. Today, the physical evidence of this work is almost spectral. There's a series of faded out, hard to follow roads, partially overgrown with vegetation, a bunch of old excavated rock piles. I mean, it's just visually striking because when you look at this, it's just not something to the untrained eye that you would really even notice. It's really has this sense that it's been lost in time.
Look at these trees. A Douglas fir forest decimated by beetle kill. A few are still hanging on. Is this part of the story?
We're tracking a 75-year-old lead on a heavy metal called thorium, and most people haven't heard of it, but it interests me because it represents a completely different way that we could be powering our civilization. It's a question of density. A single handful of pure thorium represents enough energy equivalent to about 6,000 barrels of oil. And at this specific area, there could be as much as 2,200 tons of thorium. That would be the equivalent of about 33 billion barrels of oil.
The resource was there. Nuclear was rising, but oil was already the backbone of the modern world.
Experts have to search for it constantly in all the most likely and unlikely places. The result? A higher standard of living.
I've got the reports, I've translated the coordinates, georectified the maps, and today we're going to find out what 70 years of government obscurity leads us to. In the early 1950s, the USGS and the Atomic Energy Commission were scouring the West for strategic minerals to fuel a new age. This specific area was flagged in a trace elements investigation. The reports describe these faulted and heavily mineralized Precambrian veins as a textbook environment for radioactive deposits. At the time, documents like these were labeled official use only. The US was in a desperate race to secure domestic nuclear fuel. But in that race, thorium was sidelined. It was the peaceful isotope in an era that demanded an arsenal. Because it didn't easily produce the plutonium needed for the arms race, the world's focus stayed locked on the bomb. But President Eisenhower saw a different path. In his 1953 Atoms for Peace speech, he saw a world where the atom wasn't shrouded in fear, but was used instead to pursue the peaceful advancements of humankind.
The United States pledges before you, and therefore before the world, its determination to help solve the fearful atomic dilemma, to devote its entire heart and mind to find the way by which the miraculous inventiveness of man shall not be dedicated to his death, but consecrated to his life.
Because thorium couldn't be easily weaponized, it never became the primary focus. Still, every site was mapped, measured, and recorded, carefully documented in reports and charts. The maps and legends reveal the meticulous work, even if the world's attention had already shifted. While thorium waited quietly in these pages, the rush for oil was already transforming landscapes and imaginations alike.
Yes, the real secret is not only a great source of energy, but also the freedom to make it work for everybody. And if you have both of these things, any goal is possible. It's destination unlimited.
That optimism wasn't irrational. Oil brought real abundance, expanding as new techniques unlocked more reserves. Nuclear promised something different. Energy densities far beyond anything oil could deliver. Thorium itself was largely sidelined, peaceful, abundant, quietly waiting in the background. This prospect was first surveyed in the early atomic era, when the United States believed nuclear energy would define the future. Those surveys left records, assays, tonnage estimates, but to understand what this prospect meant, you have to see the system it was part of. We need to understand the history of nuclear output alongside oil and other energy sources to reveal how it's all played out over the past 80 years. Before we zoom out, let's focus on nuclear energy alone. This first chart, called the atomic gap, shows US and global nuclear generation from 1945 to today, measured in billions of barrels of oil equivalent. We've broken the last 80 years into 3 eras. The first, the age of secrecy. From the end of World War II to the early 1950s, nuclear technology wasn't about powering cities. It was about weapons. Civilian energy was not the priority. Then, optimism arrived. Atoms for Peace. Utilities financed reactors at industrial scale. Dozens were built across the country. This is the expansion era. Momentum builds. Potential feels limitless. And then, around 1980, the trajectories diverge. The United States continues expanding, doubling output over the next 2 decades. The rest of the world accelerates, nearly tripling over the same period. But by 2000, both curves hit a ceiling. The existing fleet operates reliably, performance improves, but new construction stalls. For the past 25 years, nuclear has remained stable in output, no longer scaling at the rates of the previous decades. Nuclear accidents reinforced the shift. 3 Mile Island in 1979, Chernobyl in 1986, Fukushima in 2011. Each one compounded regulatory caution and public fear. But nuclear never operated in isolation. And this chart only goes to 2 billion barrels of oil equivalent. So now we expand the scale to see the bigger picture. Welcome to the reality gap. Same units, but now the full scale, billions of barrels of oil equivalent. First, nuclear again. Same plateau as before, small, stable, consistent, but notice its size relative to the bigger picture. Next, global oil consumption enters the picture. Look at the scale. Suddenly, nuclear seems tiny, almost negligible compared to hydrocarbons. Here's the US share, roughly 7.5 billion barrels per year. Low carbon sources are growing, accelerating rapidly, costs falling. But even with that growth, hydrocarbons still dominate the system. And here's world population, still steadily rising. Demand continues to climb. Amid all this, thorium quietly waits. This prospect holds roughly 2,200 tons of thorium, about 33 billion barrels of oil equivalent. It's one of many deposits the Atomic Energy Commission cataloged in the 1950s, when the government tried to map every possible fuel source. It's stored potential, not power on the grid, and today it remains exactly where they mapped it. A record of what was measured, most never mind. Their work ranged from broad surveys to targeted investigations, sometimes hands-on, sometimes purely observational, documenting the nation's radioactive fuel sources. These maps and reports form a vast historical record, built long before us, offering insight into the discoveries and effort that shaped our understanding of America's domestic nuclear supply. In the early 1950s, geologists mapped this ridge with astonishing detail. Their work still defines this deposit. I usually study gases born from radioactive decay, helium migrating through deep rocks, sight unseen. But here, the source is exposed at the surface. I brought a modern spectrometer, and I'm about to examine this ridge for myself. History is etched here, and I'm just beginning to trace it.